Good morning, everyone. This is Neha Sharma from Department of Mathematics at University. We are on to the first unit of discrete structures, which is set theory, relations, functions, and theorem proving techniques. Okay, so the topic that we would study today would be invertible functions and inverse of a function. Okay, um, so let's start with the topic with the today's topic. Okay, okay. So first, let's see the outlines for today's video. Okay, so first we would study the prerequisites for today's topic. Then we would have certain real life examples over today's topic. Okay, then we would have certain invert. Then we would have the definition of invertible functions. Then we would have the definition of inverse of a function. Okay, then we would have certain examples of both of these invertible functions and inverse of a function, and then we would have certain exercise for you all to do. Then we would have the learning outcomes and then the references. Okay, so let's start with the prerequisites first. Okay, so, in the prerequisites part, the first thing that we need to know is the definition of relation or the types of relations or the examples of it. Okay, so we should know what a relation is. Then we should then the second thing that we need to know is the definition of the definition of the function. Okay, why? Because if you don't know what a function is, obviously there would not be uh, any question of having the inverse of a function. Okay, because inverse of a function you can only find if you know what a function is. So if you have a function, okay, that is invertible, then only you can find the inverse of it. Okay, so if you don't know what a function is, there is no use of finding the inverse of it. Okay, so you should know what an inverse sorry, you should know what the definition of a function is. Then you should know what a one and onto function is. Okay, for all those topics we have made separate videos. If you've not watched those videos, please go back and see those videos and then come back to this topic. Okay, because there is always a chain that you should follow. So if you don't know relations, you would obviously not understand functions. If you don't know functions, you would not understand one and onto functions. And if you don't know that, invertible functions doesn't make any sense. Okay, so please see those videos and then come back to this. Okay, now let's have some real life examples over invertible or inverse function. Okay, let's see it over here. The first example would be of changing a currency into another, and then getting back to the original value. Okay, so basically what is the inverse of a function? What happens over here is inverse is the reverse process of a function. So basically if in a function we are doing something, then we would do it in a reverse order, and we would say that it is the inverse. Okay, so basically, if in a function you are going from A to B, a set A to B, then in the inverse function, what inverse of a function, what you would do, you would come back from the set B to the set A. Okay, so basically there is a reverse chain that is being followed. Okay, and so let's see the example over here. First example is that you're changing the currency. So basically, from rupees you're going to some other currency like a dollar, and then from dollar to you are coming back to Indian rupee. Okay, so this process is known as inverse process. So basically, the definition of a function is that you're going from rupees to dollars. Okay, so basically this much rupees makes a dollar. Okay, so that's maybe the definition of a function. And if you want to change the uh, dollar into rupees, then that would be the inverse process. Now inverse process is always not feasible. Okay, so there can be process where inverse cannot be formed, uh, where inverse cannot be you know feasible, cannot be there. But there are certain processes where inverse is feasible, or it can occur. So those functions are known as invertible functions, where this inverse process can be there. Okay, and if that cannot be there, then those functions are known as non-invertible functions. Okay, so basically changing of currency from one to another would be a invertible process, and obviously you can find the inverse of it. Okay, so that's pretty much an example of inverse of a function. Let's have the second example, which is also a inversion. Sorry, that's also a conversion process. Okay, so here what we are doing, we are changing from meters. We are going from meters to centimeters, and then we are coming back to meters. Okay, so there are certain questions, or there are certain like real life examples where the information is being given into meters maybe, but some of the information is being given in centimeters, or there is or it is easier to do a certain thing in centimeters. Then what you do is that you convert your meters, all the entries in meters to centimeters, and then after getting the answer, uh, you go back to meters, because you obviously want the answer to be in meters. Okay, so that's also an inverse. That's also an inversion process. Okay, so I hope the examples, the real life examples of inverse of a function is pretty much clear by this. Okay, now let's come to the real definition of invertible function. Okay, so a function is invertible if it is both what, one one and onto. We have seen what one one and onto thing is. Okay, so if a function is both one one and onto, then it is known as an invertible function, which means that the inverse of that particular function can be found if that's a one one and onto function. Okay, since one one is known as injective, we have written injective over here, and since onto is known as surjective, we have written surjective over here. Okay, so obviously, sorry, also invertible functions are known as bijective functions. Okay, acha, we have written it over here. So it is also known as bijective functions. Okay, so basically a function which is injective and surjective both, okay, is known as a bijective function. By means two, hence obviously two processes are being fulfilled over here. So mm, this is known as a bijective function. Okay, so the another name for invertible function is bijective function also. Okay, let's see an example over here. Okay, so we have a set called A maybe. Okay, and we have a set called B. Okay, so we have two sets A and B, wherein A has A, B, C three elements, and B has one, two, three, three elements. Okay, A is going to three, B is going to one, and C is going to two, which means A is going to some element, being B is going to some different element, and C is also going to a different element. That means this function is one one. Okay, it's pretty much done over here. Now, for onto what we have to check, we have to see if the codomain is equal to the range or not. Okay, so here what is the codomain? Codomain is the set B, which has three elements, one, two, three. What is range over here? So range are the set of images of the function. Okay, so it is one. Okay, one is the image of B, two is the image of C, and three is the image of A. Hence, the range set is 1 2 3 also. Okay, now the range set is equal to the codomain set. Okay, we can obviously see that equals to the range is equals to the codomain. Hence, what we would say that it is onto also. Now if the function is one and onto both, hence this would be invertible also. Okay, so this is an example of an invertible function. Okay, now let's see the definition of inverse of a function. Okay, okay, let's see the definition of the inverse of a function. So if we have two functions f and g, then we would say that f is the inverse of g, or g is the inverse of f if both of the function hold these two properties, which is g of fx is equals to x, and f of gx is also equals to x. Okay, when we say g of fx is equals to x, what does this x means? Okay, okay, let's see over here. This is a function. Okay, okay, so what do we have over here? Let's see it. Okay, this g of fx means g of f, which is the composition of the function g and f. Okay, please notice over here that this g over fx means the composition of two functions g and f, which is also denoted by g of f. Okay, now GOF is the composition, hence this is also a function. Okay. Now a function is always being applied to an element. Okay. If you're talking about a function that is being applied to to an element, okay, and that element is x. Okay. So what is happening over here is that we are applying a function over an element. Okay, we are applying a function to an element, and that function is giving us what? It is giving us the function itself. Okay, so basically what's happening over here is that we are applying a function over an element, and we are getting back what? That element only. So this type of function is known as the identity function. Okay, so this kind of function is identity function. So basically what's happening over here is that if we have two functions, okay, we have two such functions such that GOF and FOG over X is equals to X for all the elements in the domain, okay, then we would say that they are inverse of each other. So basically, if GOF over X is equals to the identity function, okay, then we would say that G is the inverse of F, and also if F OG over X is the identity function of X, then we would say that F is the inverse of G. Okay, so if okay, so if we have found a function, okay, for a particular function f, such that GOF of x is equals to x, okay, see over here, such that FOG of x is equals to x, then we would say that G is the inverse of f, okay. And if G is the inverse of f, then obviously f would also be an inverse of G, okay. So we have seen the definition of invertible functions, and then we have seen the definition of an inverse of a function. So don't get confused with both the things. What is an invertible function? A function is known as an invertible function if the inverse of it can be found. Okay, so if a function is 1 and on 2, then its inverse can be found, and then that function is known as invertible function. Okay, and what is an inverse of a function? Okay, inverse of a function is some other function other than this f. Okay, so if we have a function f, and we and that function is invertible, obviously the inverse of that function would be there. Okay, would be mm, would exist. Okay. So the inverse of it would be known as the inverse of a function. Okay, so both of these are two different things. Okay, so for invertible function we have only one function, and we check if that is invertible or not. Okay, for inverse of a function, what do? We have two functions into consideration. Okay, we have one function, and we then we find the inverse of it. Okay, so such that their composition takes the element to itself only. Okay, so that is the inverse of a function. I hope both invertible and inverse function are pretty much clear by this. Okay, now let's see what this figure has to say. Okay, so basically this is the set A. This is the set B. Okay. Now, obviously, the set A is known as the domain of F. Okay, so we have written domain of F, and this particular set is known as the codomain of F. But since all the elements of the codomain sets are the images of any are some of the elements in the domain set, hence this can also be named as range of F. Hence we have written range of F over here. Okay. I hope that's pretty much clear. Okay. For this, you should obviously be familiar with what a domain is, what a range is. Okay. So, if you've not seen the video of function, please go back and see the video for a function. Okay. So this is the range set. Okay. Now, if we want to find the inverse of it, then what should happen is that we should start from uh, this particular function, this particular set, and we should go back to this set. Okay, so this is the B set. Okay, okay. Now let's see it over here. So we have to start from here. Okay, so we are starting from this second set. Okay, and we are going back to the first set. Okay, we have returned it this way. We can also make the figure like this. Okay, we can start it from here and then this set can come to this. Okay, okay, we have reversed the process, but the figure has not been reversed. Okay, let's see the arrow. You can understand this by the use of the arrow. Okay, so this is the domain set now, and this is the range set now. Okay, so here these are the elements of domain. Now, what is the definition of function says? Okay, we have two um, points in the definition of function. The first point is that every element of the domain should have an image. Okay, so this element has image, this element also has image, and this also has image. Okay, now the second point that we have to satisfy in the definition of function is that the element that all the element in the domain set should have only one image. Okay, that should be unique. Okay, but here this element has two images. See, this element has two images, so that cannot be a case. So this is not a function. So basically what's happening over here is that we have drawn a figure for f, for the function f. Okay, we have also drawn a figure for the inverse of f, but this inverse of f is not even a function. If that's not a function, then this means that this function is not invertible. Okay, this function is not invertible, hence we are not able to find the inverse of it. Okay, I hope that's clear. Uh, let's say this again. Okay, this is the function f. Okay, this is the figure for function f. Then we have made the figure for the function f inverse. Okay, which is the inverse of the function f. Okay, but we have seen that the figure of this inverse function tells us that this is not even a function. If that's not even a function, which means there is some fault somewhere. Okay, so this particular function was not even invertible, hence we are not able to find a inverse function. Okay, okay. Let's see what is the fault. The fault is that this function was obviously onto. Why onto? Because codomain was equals to range, but this function was not one because two of the elements are going to one image. Okay, so basically we have two elements in the domain set which have the same image. That means this is not a one function. If that's not a one function, that is not an invertible function. If that's not an invertible function, obviously the inverse would not exist. Okay, only an invertible function would have its inverse that will exist. Okay, so we have tried to find the inverse of it, but we are not able to get that because this is not self a function. Okay, we have made a function, but that was violating the definition of function. Okay, now I hope the definition of inverse of a function is pretty much clear uh, by this figure. Now let's see how to find the inverse of a function. So if you're given with the definition of a function, then how to find the inverse of it? Let's see. So the first step would be replace the function fx, replace the function fx by y. So what is the first step that we have to do? So you are given with the function, say suppose fx is equals to x square. Then what you do? You would replace fx by y. So it would become y is equals to x square. Okay. So that was the first step. Then let's see the second step. Swap the variables x and y. Okay. So we would swap the variables by, okay. So it would become x is equals to y square. Okay. We are swapping the variables. Okay. So basically x is becoming y and y is becoming x. Then we would solve for y. So basically from there you would find the value of y. So it would become what? Y is equals to under root, like plus minus under root x. Okay. Then we would replace the value of y by the inverse of fx. Then instead of y we would write f inverse x. Okay. So it would be f inverse x is equals to plus minus under root of x. Okay. So that would be the inverse process. Okay. So by these four rules or steps, we would get the inverse of a function. Okay. Now let's see it over here. Mm, we have a question. X is one two. The values of x are 1, 2, 3, 4, and the value of hx is 2, 1, 2, 5. Okay. So basically, what is the function? The function is hx. Okay. We have named the function value as hx, and what we have to find, we have to see if the function is invertible or not. Okay. And so we have two process of doing that. The first one is that you can see if that is one or on two or not. The second process can be just find the inverse, just try to get the inverse and then uh, see if that's feasible or not. Okay. Now let's see. So since we have a very small number of values, okay, we have a very few number of values. Hence, we have drawn the figure. Okay, so the domain set is 1, 2, 3, 4, and the codomain set is 1, 2, and 5. Okay, why 1, 2, and 5? Because see over here, we only have three values, 1, 2, and 5 over here. So the codomain set is 1, 2, and 5. Okay. Now, what we have to do in the inverse function? So, in the inverse function, we start from the codomain set and we get the value back into our domain set. Okay. So, we would start with the codomain set and then we have to get the value in the domain set. Okay. So, 1 is obviously, see, 1 is going to 2. Okay. So, 1 would go to 2 over here. And here 2, 2 is being mapped with like 1 and 3. So here 2 would go to 1 and 3. Okay. And then here see 5 is being mapped with like 4. So we would map 5 to 4. Now here also, let's see. 2 is being mapped to 1 and 3. Okay. Now in the definition of a function, we have two things that we have to satisfy. The the first point is that every element in the domain set should have an image. So this is the domain set now. So 1, 2, and 5 all have images. That is correct. But the second point is that all should have unique images. Okay. But here 2 has two images. Okay, 1 and 3. Hence that is violating the conditions of function. Okay, hence this is not a function. If h inverse is not a function, which means h was not an invertible function, hence we cannot find the inverse of that particular function. Okay, so h was a function where the inverse cannot be found. We were doing it deliberately, but we cannot find the inverse. Okay, let's read this. Notice that H inverse maps the input of two to two different outputs, which is 1 and 3. This means H inverse is not a function. If H inverse is not a function, which means H was not an invertible function. Okay, not a function that we can find inverse to. Okay, I hope that's pretty much clear. Now let's see the example of inverse of a function. Okay. Find the inverse of fx is equals to 5x minus 7. Okay, so you have to get the inverse of it. How to do that? Let's see this. The first step was replace the function of x by y. So let's replace it by y. Okay. So after replacing it by y, it would become is equals to y is equals to 5x minus 7. Okay. This would come as say. Okay. So y is equals to 5x minus 7. Then what is the second step? The second step was swap the variables x and y. So let's swap the variable. It will become x is equals to 5y minus 7. Hence we have got sorry. Hence we have got x is equals to 5x minus 7. Okay. Now what we have to do? The third step, what? See this, the third step is solve for y. Okay, so we would solve for y, so we would basically have to find the value for y. For that we have to take this 5 over here. Hence it would become y is equals to x plus 7 by 5. Okay, so it is y is equals to x plus 1 x plus 7 by 5. Okay, what is the fourth step? The fourth step is replace y by the inverse of fx. Okay, so we would write y as the inverse of fx, which would be f inverse x. So f inverse x is equals to x plus 7 by 5. Okay. I hope this is clear that how to find the inverse. So we have basically four steps. The first step is that you have to write y instead of fx. Then the second step is that you have to swap the variables. Okay, here we have like swap the variables. Then you have to get the value for y. Okay, here we have got the value for y. Okay, here. Then what you have to do, you have to put f inverse x instead of y. So it would become f inverse of x is equals to x plus 7 by 5. Okay. I hope how to find the inverse of a function is pretty much clear by this example. Okay, let's see one more example over here. So we have a function like this. So it is 2x plus 5. Okay, 2x plus 5. Now what we have to do, we have to write y instead of fx. So it would be y is equals to 2x plus 5. Now, there is another method to find the inverse of a function. Okay, this is basically a shorter method, you can say. So basically, we would write y instead of fx, so it would become y is equals to 2x plus 5. Okay, after that, what you have to do? Let's see. Then 2y plus 5 is equals to x. Okay, how this has came? You have basically swapped. Okay, so it would become 2y plus 5 is equals to x. Then you would get the value for then you get the value for y, which is x minus 5 by 2. Okay, so it would become like this. Okay, or else what you can do is that you just write 2x plus 5 is equals to y, and you get the value of x from there. So it would be x is equals to y minus 5 by 2. So this x would be the inverse. So it would be f inverse y is equals to y minus 5 by 2. Okay, from this particular step only you can find the inverse. Okay, so we can have two methods. If you want to stick to one method, then please stick to the previous one. Okay, that we have already been done. Otherwise, you can obviously obviously go to the shorter method that I have told over here. So let's see this question once again. What you have done, you have written y instead of what? Fx. Okay. Then what you have done, you have swapped both variables. It would become 2y plus x plus 5 is equals to x. Then you would find the value for y from this equation. So it will become y is equals to x minus 5 by 2. Then this 5, instead of this 5, you would write f inverse x. So it will become f inverse x is equals to x minus 5 by 2. Okay, so this will be the inverse of fx. Okay, I hope how to find the inverse of a function is pretty much clear by this example. Okay, we have done two examples, so obviously that is pretty much clear by this. So basically, what we have studied in today's video, uh, okay, let's first see the exercise, then we would revise that. Okay, so this is the exercise for you all people to do. Okay, please do this. Okay, otherwise this would be very difficult if you got the got today's topic or not. Okay, let's see. So fx is equals to x square. Okay, fx is equals to x square, be an invertible function. Sorry, we have a function which says fx is equals to x square. You have to check that if that is invertible or not. Okay, then the second question is that find the inverse of fx is equals to 7 plus 4x by 6 minus 5x. Okay, so that's a question. You have to find the inverse of it. Okay, for finding the inverse, we have obviously written 4 steps in the previous slides, so you can obviously refer to that and then do this. And then the third question is the function invertible? So we have given with a function. We have also done a question like this in the in today's video. So and please see this. You have given with the values of x's. You've given with the values of fx's. What you have to do over here is you have to check if that is invertible or not. So basically, you have to check whether the function is invertible or not. Okay. Now let's see what we have learned in today's video. In today's video, we have seen the concept of invertible functions and how to find the inverse of a function. Okay, we have seen two things. The first thing is invertible functions and the second thing is inverse of a function. For invertible functions, we only have one function into consideration. So we have a function called fx. So we have to see if that is invertible or not by checking the one and onto criteria. So if the function is one and non-two, then we would say then that function is bijective or invertible. Okay, and if a function is invertible, then it would have an inverse. Okay, now inverse of that particular function would be some other function. Okay, what is the property of an inverse? So the property for inverse of a function is that it would give the identity function as the answer uh, if you find the composition of both the functions. So basically, if we have an invertible function fx, then we would have an invertible function gx such that fog of x is equals to x for all the x's belonging to the domain of uh, g. Okay, and also gof over x is equals to x for all the elements belonging to the domain of f. Okay, so this is known as the inverse of a function. Okay, I hope invertible functions and inverse of a function is pretty much clear by today's video. Okay, and also we have seen how to check whether the function is invertible or not, how to find the inverse of a function. Okay, we have seen all those things over here. So I hope the topic is pretty much clear by this. These are certain references that you can follow, and also this is a site from where I have taken the question. Okay, so you can obviously refer to the book number 1 and 2 for this topic. Okay, thank you so much for watching the video. Do practice the questions at home, otherwise the topic would not be that beneficial. Okay, uh, so please study and be safe.